Or did I miss something? Oh, I should reread the question. Did I do everything in example 1?
Did.
Awesome. Okay. Example 2, it says determine the exact values. Actually, we are only going to do 2b right now. We're going to leave 2a until after we have done our major circle project, because we're going to make a unit circle and put all the memorized values on there. So anything with exact, we're going to leave for later. Okay? But we are going to do approximate values of the 6 trigonometric ratios, and you're like, 6? I thought there was only sine, cosine, and tangent. What are the other 3? Well, if you turn back a page, they introduce, there we go. They introduce 3 new trig functions for grade 12. They are the reciprocal trig functions. So the reciprocal of cos is the secant. Actually, this is on page 470. Before we get to example 2, we're going to talk a little bit about some stuff before that. But the secant ratio is the reciprocal of the cosine ratio. We have the cosecant ratio as the reciprocal of the sine ratio. And the cotangent ratio is the reciprocal of the tangent ratio. And you're going to have to know these. Now the cotangent one, super easy to remember because it's related to tangent. And you have to somehow think of how am I going to remember that cotangent goes with tangent. It probably won't be very hard. There's probably something in the words there that'll be easy for you to connect. But these ones are going to maybe mess you up. Is it going to mess you up that secant goes with cosine and cosecant does not go with cosine? Cosecant goes with sine. Oh my goodness. Is that going to mess you up? Yes. So you somehow have to remember that cosine goes with secant, and cosecant goes with sine. And now I'm going to get you to turn back to the last page right before this, and we're going to get introduced to what I like to call the 3 big ideas of this chapter. And almost every question that we do is somewhat linked to these 3 ideas. So this is, if you turn back to page 469, we're going to start with, here it is, highlighting a definition. The first definition that we're going to highlight at the bottom of page 469 is the definition of the unit circle. All the unit circle is a circle with a radius of 1, meaning it has 1 unit for its radius, and they call it the unit circle as a result. Now, there are some crazy things that happen with the unit circle related to trigonometry. So now we start taking trigonometry and not just think about triangles, we also connect it to this circle. First of all, is if you take any point on this circle, wow, that's a big yellow. I'll go small and blue dot. Would you agree that the radius is always 1 on the circle? So any point that I pick on the circle will be exactly 1 away from the origin. If I take that point and I make a triangle back to the nearest x-axis with my reference angle, no matter where I pick it, I will make a right-angled triangle. The bottom of this right-angled triangle will be the same as my x-coordinate. The top of this right-angled triangle will be the same as my y-coordinate. So if I make a triangle, the point, this part will always be my x point, this part will always be my y point. And if I do SOHCAHTOA, and I have that reference angle there, which in this case happens to be the actual angle in standard position, then sine of theta is the opposite side, which is y, over the hypotenuse, which is 1, which is just y. I do the same thing with cos, and cos of theta is adjacent side over hypotenuse, which is just x. And you have either space on page 699 or on the bottom of page 470, and I would like you to write out the first big idea. Big idea number 1. Big idea number 1 is now, instead of using x and y for points on a circle, you can use the angle in standard position and cos theta and sine theta. This is like big idea number 1 from our chapter. Big idea number 2. Did you know that the equation of a circle is just a squared plus b squared equals c squared? If I draw this triangle, a squared plus b squared equals c squared. The radius is 1. This side is x, this side is y. I get x squared plus y squared equals 1. So if you use a squared plus b squared equals c squared for a triangle, and that triangle, no matter where I put the radius, is always 1, putting them all together makes the equation of a circle. If you use big idea number 1 with the Pythagorean theorem or the equation of the circle, big idea number 2 says, well, if the x is cos, and I squared, and the y is sine, and I squared, I will always get 1. This is crazy. This is big idea number 2. Mathematicians don't like brackets because it's not simplified, and then they look for notation ways to shortcut. But the problem is if I take away the brackets, how do I know that I want the whole thing squared and not just the angle squared? So mathematicians have decided on this, and this is the first formula on your formula sheet, this big idea. They like to write the sign first. I don't know why, it doesn't matter. But when they square sine, they put the squared in between to save brackets. And cos squared theta will equal 1. Big idea number 2, we're going to do some mental math now without your calculator. Okay? I'm going to pick an angle, 17 degrees. In your head, I want you to do sine of 17 degrees only to 11 decimal places. Okay? Got that number in your head? I now want you to square that number. Square that number. Also, 11 decimal places is fine. Remember that, put it off to the side. Now, I'm going to do cos of 17 degrees in your head. Also 11 decimal places. Remember that. Now take that number and square it. Now you have two answers in your head. Add them together. What do you get? Wow. Amazing mental math. That's right. You add them together, you get 1. It doesn't matter which. Here. So just to look at the mental math that she did, first of all, you make sure that I'm in degrees. I'm not. My calculator degrees. So this is what we did. We did sine of 17 degrees. Right? That's not even as many decimal places as you remembered. Very impressive. That's only 10 decimal places. You remembered 11. Right. What's the number after this? Perfect. Okay. We're going to square that number and memorize that. Then the next thing we did is we did cos of 17 degrees. 11 decimal places. What's the number after? So good. Okay. And then we squared that. And then I said, take this number that you had here and add it to this number here. Get 1. And that works as a big idea. That works every single time. Okay? Now everybody knows that she didn't actually do those numbers. Sorry. Right? We didn't actually do any of that mental math. We just used the big idea to figure it out. And from our picture, so I'm going to slide up, and on our picture, the last thing I didn't do is I didn't do tan of theta. Tan of theta is your opposite side, so that would be y, over your adjacent side, which would be x. The SOHCAHTOA of tan is opposite over adjacent. But if your y is really sine of theta, and your x is really cos of theta, we get to big idea number 3. That tan of theta is sine of theta divided by cos of theta. And we can check this on our calculator with 17 degrees. If I do tan of 17 degrees and push enter, and then I check what's sine of 17 degrees divided by cos of 17 degrees, I get the exact same answer to all decimal places. Tan of theta is always sine of theta over cos of theta. And in this unit, if you get stuck on a question, usually one of these 3 big ideas can help you get unstuck. All right, so that's where we'll end. We'll do example 2 tomorrow.